Hi everyone, let's solve this problem. Container with most water. Let's understand the problem statement. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of ith line are I comma 0 and I comma height of I. So basically, let's read the other statement as well. Find two lines that together with the x-axis from the container such that the container contains the most water. Return the maximum amount of water a container can store. So basically, this is the axis and this is the height of the vertical lines. So now what they're trying to say is basically you can have the edges on both of the ends and you should calculate the maximum water contained in that two edges. Let's say for example, if I am taking this one and the vertical line of height 1 and the vertical line of 7 at this, so the maximum water I can store is basically only of height 1 and the width can be 1 2 3 4 5 6 7 8, right? That is how much water I can store over there, 8 units of water. So basically how do I get to know that? Basically I'll take the minimum of two vertices. So minimum of the two line heights is basically 1 into the edges in between. So nothing but if we take the indices, okay, let me copy this and give the indices to them. So basically if I take this 8 minus 0 would be 8 into 1 units will be 1. So this is the reason why we are able to get the total water content as 8. So how can we get the maximum? Basically for between every two edges you will find the area. So water content is nothing but area. Generally area's formula will be height into width, right? And here height will be what? Minimum of, let's say if I am taking height of I comma height of j as two of the vertices, to like height of I, let's consider height of j, then what will I do? I will take height of I comma height of j minimum and then I will multiply the width. How will I get the width? I will get width is j minus I. This is how I get. So we can do it for every edge. Let's say for example, what I'm trying to say is if I'm iterating over all the then j is equals to I plus 1 because we are checking from the first edge to all the edges, so we don't really have to go back again because we are kind of recalculating them. So j is less than height dot length j plus plus. Now let answer is equals to 0. What should be my answer will be, okay, we will calculate it in a different. Current area is equals to math dot min of height of I comma height of j and we have to multiply into the width. How will we get the width? J minus I, because j will be always greater than I because j is always starting from I plus 1, so it will be j minus I. Now my answer, if my current area is greater than, that means if my current area is greater than my answer, I will just update it and then towards the end we will return the answer. Obviously this solution should not work because the time complexity is big of n square and it does not fit into our time constraints. So let's try to run this solution and see. Okay, let's submit it. It should give us time limit exceeded because of the constraint. Now let's try to understand a better solution. So let's say, for example, if this is the given edges or the vertices of line heights, so the maximum area can be between the first line and the last line, and if they are of the maximum height, that is the area. So can we, in the area formula, we have height and width. So basically we are taking the maximum width by keeping the 2 pointers, one at start, one at end. When we do that, we are very sure that if there are two edges which are having the maximum heights, it will give us the maximum area that we are sure of. Then height will vary. Now height is the only variable here. In that case, what should happen? I should discard always the minimum height, right? If I discard the minimum height, what will happen? I will be able to move to a better height line, and then we will again calculate it. So that is what is happening here. So let's say I have 2 pointers. Let me write the code for this as well. Let's say the left is at 0 and let right is equal to height dot length minus 1. I have this. I will keep checking left is less than right, because we at least need 2 bars and we have to calculate the area, right? So in this case, what will I do? First I will calculate the area. Area is nothing but I have to know the first is minimum of these two and then width. So math dot min of, what are the two bars which we have selected? One is left, one is right, and we will be multiplying into, right is always greater, so right minus left. And then what will happen here is that we have to again update math dot max of our answer comma my current area, which is in the variable area. Now what should happen? I have to move my smaller, let's say for example, if there is a smaller height on the left, I have to move my smaller stick. If my height is on the my height is lesser on the right side, right pointer should be moved. So let's say height of left is less than or equal to height of right. Then what should I do? I just have to increment my left, else I just have to increment right, decrement the right, because we are coming from the end. Now one more question is that when they are equal, it does not matter either you increment left or decrement right, because they are of the same height. So now let's try to run this solution. Let's submit it. Yeah, it works. So now let's try to, and the time complexity of this solution is nothing but big O of n, because we are just iterating over all the elements in the array at max once, and there is no extra space used, so the space complexity is big O of 1. Let's try to understand in detail why this solution works. This solution works because first of all we are considering the maximum possible width, and then we are kind of trying to reduce the width. So when you are reducing the width, we should ensure that the height is increasing. That's when you get the product as maximum, right? if one of them is decreasing, we cannot decrease both of them and still get the maximum. So that is the reason it works. I hope, let's say for example, area and height into width. So let's consider the width first. So we are first of all taking the maximum width possible. So in this case, the first and last will give the maximum width, and now I got some maximum answer, max area. So now I should also find maximum areas in between them. So I am kind of reducing my width by reducing either the right or increasing my left. I am reducing the width when my width decreases. If my height does not increase, then in that case it will always be less than my current width, right? Because of which, if one of the parameter is decreasing, that means we also have to check the other parameter increases. That is the reason the height should be maximum of the two. Whichever is maximum, we consider that and we discard the other stick. Okay, I hope you understood the solution. Thank you.